In the previous video, the simulation results showed an EUI of 384, which is much higher than the baseline. The baseline is the average EUI in the 2003 National Survey of the existing commercial buildings. To design a high-performance building, we should target an EUI that is much lower than the average EUI in the early 2000s. Let's try to lower the energy consumption by shooting in the dark. Let's try to increase the R value of the exterior walls. To do that, click on the pencil icon to modify the zone. Then click on the pencil icon in the construction section to modify the envelope properties. The elements for the building envelope are listed here: roof, exterior facade, interior partition, interior slab, external floor, ground slab, and ground wall. It also shows the thermal properties of the assemblies. On the right side, the cyan lines denote where each of the elements is referring to. You can click on facade to change the R value of the exterior wall. The thermal property of the wall are listed here. You can click on this icon to switch between the unit systems. The layer of the wall are listed here with the thickness information. The section here shows the assembly. Here is the outside and each of the layers, and here is the inside of the wall. If you look at the list, the current assembly is locked, so we cannot make modifications to this wall. We can make a copy by clicking on this plus icon, set the name to, let's say, high performance wall, and click OK. At the bottom of the list, you can see that there is the wall we just duplicated. Click on the pencil icon to modify it. Let's make the insulation 4 times thicker. And add another layer of insulation by clicking on the plus sign. Set the thickness to 0.025, which is about an inch. Double click on the default mat to change the material. Let's use XPS. And click OK. Now you can see there is a new layer of 1-inch XPS. Let's move the layer above the concrete. In energy modeling, you can ignore very thin layers such as mesh wire, house wrap, etc. Now you can see that the new wall has much higher R value. Let's click OK all the way to close the windows. We just created a custom wall with a much higher R value. Let's run the energy simulation to see how much energy consumption has reduced. I want to save the previous simulation for comparison, so click Yes. The UI has dropped slightly from 384, but not as much as many people would expect. You can further increase the R value of the roof with the same process to reduce the energy consumption. I just increased roof from R31 to R68. Let's run the energy simulation to see how much energy we can reduce. The EUI again dropped, but slightly. You can also use high-performance windows. Let's modify the zone again, modify the construction, click on the Exterior Windows tab, and you can select a different glazing here. You can see that this is a double pane glazing. Let's click on Type to sort by type. Select a triple pane glazing, click OK. Click OK all the way to close all the windows. Let's run the simulation again. Changing the windows to triple pane glazing has lowered the UI about 10%, but still way higher than the baseline. In this video, we learned how to improve the thermal properties of opaque surfaces and choose high-performance windows. However, You also saw that the EUI did not drop below the baseline easily. In the next video, we will diagnose the simulation results and optimize the design based on the simulation data.